This is a buffer lab, and it's the acid-base buffer lab. And what I'd like to do is I'd like to read what you guys have on your sheet. I'd like you to read along with me. It helps to explain what a buffer is and what we're going to be doing in this lab. In this lab, a buffer system simulates one that is found in human blood. A buffer system acts by being able to absorb excess acid and excess base that might be present. It therefore prevents the pH from shifting quickly and helps to maintain it at current levels. For example, in your body, we have lots of molecules that act ideally around a neutral range, around 7.0. So our blood needs to be always constantly at that pH. If we start to change the pH, then actually that's going to start to change the shape of our molecules and our proteins inside of our body, and we wouldn't really be able to have any more cellular functioning if that were to take place. So this is to show how a buffer helps to resist that pH change and keep the pH close to what it's supposed to be. However, it will not act indefinitely, as molecules in a buffer system will eventually be used and the pH will then change. Thus, a buffer system acts to resist the pH change. Note here, it does not stop a pH change. A buffer helps to slow or resist a pH change. That's the main concept of this lab. In this lab, the buffer will act by allowing the solution to absorb a large amount of hydrochloric acid before a color change and a pH change is observed. So I have some instructions here. I'm going to be kind of going through these with you guys. And you can see that I have two beakers. We have beaker 1 on the left. We have beaker 2 on the right. This is filled with 30 milliliters of water, and this is filled with about 25 milliliters of water. So I'm going to be adding something to that in a few minutes. So I have set up our pH probe. We can see our pH probe over here, and we can see that the pH is close to neutral. It's about 6.98, very, very close to 7, so I've calibrated that, and we're going to come back to that in a few minutes. So what I'm going to do is I'm going to be adding 3 drops of the rainbow stain or the universal indicator to this over here, and what I want you to do is record the color. 1, 2, 3. Okay, so you can see that this color is on the green scale. Okay, it looks like it might be around somewhere between a pH 5 and a pH of 6. So we can go ahead and say it's kind of green for the initial color. Okay, and the pH on the chart indicates that it is about a probably about between a 5 and a 6. Okay, and then what we're going to do now is we're going to add 3 drops of hydrochloric acid. So here's my hydrochloric acid over here. I'm going to add 3 drops of this to beaker number 1. So there's nothing in here except the rainbow stain. Now I'm going to be adding these 3 drops, and we're going to see a rapid change in the color. 1, 2, 3. So I've just added 3 little drops of this, and you can see that the color changes very, very quickly to between a 2 and a 3. Not quite yellow, not quite orange. So this goes to a yellow, and that's going to be about a 2 to a 3. So this is an example of an unbuffered solution, since it doesn't have any buffers in it. But note how quickly the color and the pH changed. Okay, so we're going to put this one aside, and then what we're going to do is we're going to create our buffered solution. So again, I have about 20-25 milliliters in here, and what I'm going to do is I'm going to be getting some of this, and this is going to be acting as our buffer. This is just baking soda. It's 0.1 molar, so it's not very, very concentrated. And I'm going to add this into our thing here. Okay, so now I've brought that up to 30. Okay, so and what we're going to do is after this, we're going to record the actual pH of this using the pH probe. So I'm going to be getting the pH probe and testing this, and I'll show you what the pH is going to be indicated. I'm going to rinse this off. I'm going to put this into the solution and then bring it over here. The pH actually has gone up. And the reason why it's gone up a little bit is because baking soda, if you remember, baking soda is not an acid, it's a base. So it's increased our pH. Around a pH of 8 is what we would expect from this. So we're going to record 8.00 for that. So we're going to come back here and record the pH is going to be 8.0. Okay, now I'm going to bring our sample back. So here's our sample, and what we're going to do now is we're going to add 3 drops of the universal indicator to this. 1, 2, 3. And if you look at that, we are now sort of off the chart. Because remember, we're actually at about a pH of 8. So by adding this base shifts it from being neutral water to being more basic. Okay, so I added the volume of the base to this to make it 3 milliliters. Now what I'm going to do is I'm going to record the initial color. The initial color actually is purple, so if you can record that. And what I'm going to do now is we're going to add hydrochloric acid till we get back to the initial color. So I'm going to be adding some drops of the hydrochloric acid to this, and we want to try to match it to this color right here. So if you remember, how many drops did it take to turn that into that color? It took about 3 drops. Okay, how many drops is it going to take? We have to count drop by drop. So we're going to add the hydrochloric acid drop by drop. We're going to count the number of drops, okay, until it matches the color of that. So I'm going to be stirring with this over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so those two match each other. The number of drops was 20. We brought it back to this yellow coloration. Okay, so we're going to be discussing this in the next part.